So let me move on, okay? If we have more time, we come back to this. Let me move on to MC3. MC3 is for AIME level, okay? You want to do better in AIME. You have let's say the AIME questions. There are 15 questions, okay? You have 3 hours to work on it, so that's a lot of time. But the first 5 questions usually accessible to anyone who actually have some experience. You passed AMC 10 or 12, you could do the first 5, but the last 5 usually are hard. In the middle, the difficulty is medium. So you want to do better. You want to do at least 8, 9 or questions in the AIME to get to qualify for the next level. 8 is not even enough. Okay, 9 is borderline. If you get 10, I think you're guaranteed. Okay, so let's look at the question number. Yeah, let's look at question number 10. Okay, question number 10. Yeah, I got a typo here, capital O. So well, just solve for x. Okay, so this one, this kind of equations. Okay, we know how to solve quadratic equations, but this is quartic. Okay, degree 4. So that's kind of a hard. Okay, unless you see very clearly how to factor it, it's not easy to do. All right. So so in this case, what's special about this equation? And can anyone tell me what's special about the equation? Symmetry. Exactly. It's the coefficients are symmetric. So in this case, we could do a special trick. Okay, let me show you the special trick. So first of all, we divide everything by x squared. We can do that because x equals 0 is not the solution. Okay, x equals 0. Look at this, it's not the solution. So we can divide by x squared. Now the question becomes 2x squared minus 9x plus 14 minus 9 over x plus 2 over x squared. Yeah, some people already see the trick and some people already see some solutions. Okay, so let's look at what I do on board. Okay, all right, so what we can do, if you recognize x equal 1 as a solution, you can do continue. Okay, but for those of you who want to follow, okay, who want to follow my procedure, please go on to look. Okay, so okay, so let's go on to finish this one. So I'm going to combine these two terms, and that's going to be 2x squared plus 1 over x squared minus, and then I'm going to combine these two terms, 9x plus 1 over x and plus 14 equals 0. So if you ask me, where does it come from? Why? How do we motivate this thinking? Well, this is a trick we can apply when the coefficients are symmetric. Otherwise, this is not going to work. Unless in the most cases it's not going to work. So you first of all you do symmetric coefficients, and then you do have these kind of patterns. Okay, so the patterns you can do x squared, 1 over x squared, x and 1 over x. So reciprocals. This equation is called reciprocal kind of equation. Reciprocal equations. So what do we have for this? We can change a variable. Do a change of variable. Call it y. Yeah, some people already written in the chat room, so I'm going to write. I'm going to elaborate on this. So what is y squared? If you're familiar with the square formula, you can do x squared. You know it's x squared plus 2 plus 1 over x squared. So that's exactly you have in this one, subtract 2. Okay, so that means 2 times y squared minus 2 minus 9y plus 14 equals 0. And what is the simplified? Okay, 2y squared minus 9y minus 4 plus so this is going to be plus 10, okay, equals 0. And then it's a quadratic equation. You can do factor, you can just use the quadratic formula, whatever you use, okay. So this is going to be 2, okay, so factor it, it's y minus is it y minus 5? Y minus 2, I think. There's y minus 2, and 2y minus 5 equals 0. So the y could be equal to 2 or 5 over 2. And those, after you do those, you can put it back here and solve for x. That's another quadratic equation. So then some people already gave it the solution x equals 1, actually a double root. Okay, and x equals to 1/2 and 2. Okay, so there are 4 roots. Okay, yeah, so good questions about how did the first guy who thought about doing it. That I don't know. I don't know, but the thing like this is that people just do all the crazy kind of things to solve it. For example, the ones in the 18th century, the ones who came up with solutions for cubics, those really smart methods. Okay, so when people do this, try different things a lot of time, they find out something smart. Okay, all right, so. Yeah, let's look at the MC4. So